going to talk through now the systems and how timber frame works. Obviously this morning I was saying to you, obviously with our TechVantage systems, the 3 systems which are in front of me. And then I'm going to show you the process of the construction, because again, sometimes when you see it in 2D, it doesn't look quite the same as 3D from a point of view of the different systems and the different liners and that. So in front of me now, you can see the 3 different systems. So we've got the Tech-E, TechVantage S and TechVantage T system. And as we were saying, and as the conversations I've had with a few of you before lunch, it depends on your drivers as to which system you want, whether it's cost, whether it's energy efficiency, whether it's thinnest wall, or whether it's natural insulation. Most of the systems at the moment, I would say the lion's share, we're going down the TechVantage E system. The TechVantage E system gives us 140mm wall structure with 100mm of polyurethane factory fitted in the panel. So the panel comes to site like that. So when you look at the panels here, they actually come with that 100mm in the panel, so that from breather paper to stud, doesn't change whether we're building to building regs or whether we're building to sort of near passive house. What changes is the liner on the inside. And so the idea being that liner on the inside is what is reducing your cold bridging and bridging factors through the stud. So obviously you've got cavity outside, studs, any cold air from outside tracking through. That liner on the inside then is almost like a thermal blanket. So the idea that is then wrapping the whole of the external walls of your timber frame, so that you turn around and they've got no direct contact then from your service battens and plasterboard to the actual superstructure. That liner then can be anything from 20mm up to 100mm. So if we're, like we were talking to Frank and Pauline Mace this morning with theirs on a 0.1 U value, that liner inside was 100mm. So, but even then, people think, well, that suddenly starts to make a thick wall. It doesn't, because obviously on the outside of that, they were using a counterbatten and a render board. So you haven't got that sort of nominal 2-inch cavity, 4-inch masonry on the outside of it. That's delivering us from U values of 0.19 down to 0.1, 0.09. So phenomenal performance out of that. And again, on the outside of it, you can see we've got different membrane colors. So if we've got a masonry cladding on the outside, we use the silver membrane, because then that works on reflectivity. If we've got a lightweight cladding, then we use the red membrane. It's amazing now, really, how most of the builds we're doing, 4 out of 5 of the builds are lightweight cladding. Because the cladding is purely a cladding, there's no structural element to it whatsoever. Masonry has sort of disappeared now, and obviously with trying to increase the thermal envelope of the build, if we've got a 2-inch cavity and 4 inches of masonry on the outside, and we can turn around and reduce that to sort of 50mm, we've gained 4 inches all the way around the inside of the house. So your habitable area has got bigger without your overall footprint as such like that. So that's your TechVantage E system. Then we go to our Tech-S system, and as we said, the difference between Tech-S and Tech-T is they're breathable systems over the Tech-E. So the Tech-S system is very, very much mirrored on U values to the Tech-E, but Tech-S is a hybrid system. So Tech-S is obviously, as you can see there, has got natural insulation in it. That can be anything from a glass wool to a rock wool to a warm cell to a sheep's wool to sort of hemp, any of that sort of insulations. But what you need to think about is, because it's a natural insulation, the actual thermal properties of it are less than obviously with polyurethane. So we have to turn around and make the walls, we have to have a bigger thickness of wall to get that lower U value. So with the Tech-S system, obviously within the 6-inch stud, we're only achieving about a 0.2 U value. So the idea with that is you don't make the panel thicker, because if you make the panel thicker, you have thicker studs. That means you increase your cold bridging and you increase the timber percentage of the panel, which again reduces your performance. So the idea with the Tech-S system is we put a liner again in polyurethane on the inside face. So again, that can be 20mm, 30mm behind the service battens. So that works as a hybrid. So you've got breathable through the wood fibre, through the natural insulation and back out, and then your polyurethane liner on the inside to help keep the thickness down, so that then gets you your lower U value. So that gives you a hybrid solution of the Tech E system. Then you go across to the Tech T system, which is the sort of big brother and looks as snug as a bug in a rug. But people say, crikey, that looks massive. That's just going to take all my floor area. Tech T system, 270mm wide with a 35mm wood fibre on the outside, the 9mm OSB on the inside again. No connection, only connects top and bottom between the two studs. That is what we call a separated stud system. The poorest that can deliver with a natural insulation, as you're looking at it there now, is a 0.13 U value. The poorest it can deliver. So it's phenomenal, really. But how it performs so well is because obviously the studs are separated. So whereas these two systems, you have a timber fraction, which is the timber volume per cubic meter of the panel. Because these are solid studs, you're working on about 14.5%. With the twin frame system, you're down to 6.5%, literally half. So, and the idea being then is your inside skin is load bearing, your outside skin is not. So as you saw through the presentations this morning, our floor joists then sit on the inside skin, and then we put a runner on the outside, and then we go up a level again. So the outside skin is purely picking up the cladding and holding the insulation in the panel. So there's no bridging factors or anything through it. That, as it looks, as we said, will deliver you a 0.13. If we put a foil on the inside, we can get it to a 0.12. And again then, if we want to turn around and hybridize it with a polyurethane to go to 0.1, 0.09, we can do that, or we can make the wall slightly wider. Because if we take that wall to 300mm, plus the wood fibre, plus the liner, we can achieve 0.11. Because of the natural insulations, if you want to go natural completely, we've got to make that wall wider. It's always a thought process, and as I said, we spoke to a few this morning, think about what that key driver is. Is it thinnest wall, best performance? Is it a combination of both, or is it exclusively going over to natural? They're like that. So behind me, once you've sort of gone through the systems, people say, right, well, actually, I'm looking at building timber frame. What base can I put it on? What foundation can I put it on? You can put it on any foundation you like. But with a timber frame, it's an engineered solution. So it isn't a matter of, oh, my mate Bob the builder did a job down the road 6 months ago and your house looks similar to that house. The foundation will be similar. We'll do the same. No. You might have done that before, we don't do that now. It's an engineered solution that's going above ground, so we want an engineered result of what's going below ground. So we will design the timber frame, we will then turn around from top down, work out the load paths and work out what we call the line and point loads of that timber frame. We will then give that to a foundation engineer, and then based on what they call the soil test of the ground, where the area where the plot is, they will combine saying, right, the foundations need to be this design, that design to that depth. And we need to do that because your structural warranty guys and your warranty guys these days, again, they're all wanting that soil test done and they want to join those dots up. It is, as I said, you can't just do what you've always done. And also it's a fact of in the ground is expensive. So you can make your money on that project or you can lose your money in that project in the ground. So yeah, again, I always say to people, do not drop a bucket in the ground until you know what build system you're using and you've got the loadings to know what's going on top of it. Too many times we'll get a phone call, Simon, thanks very much for your quote. We're nearly ready, we're near enough ready to go now. We just need to tidy a few things up, but I just want to ask you a question. Once we order it, how soon can you come out and measure the foundation? We don't come out to measure the foundation. You put the foundation into our design. Why have you gone and put the foundations in? What have you saved? Nothing, because you've gone and put that foundation in and my lead time is still 14 weeks. So you've put that foundation in and you could have overspec'd it, underspec'd it, and it's now going to sit and grow and do nothing for 14 weeks. So you haven't actually saved any time like that. So take that and nugget away. Do not turn around and start in the ground until you've got our loadings. But that aside, can we put a timber frame on a raft foundation? Yes. Can we put it on a block and beam foundation? Yes. We can put it on any kind of foundation, but as we said, it needs to be designed for it, because as you've seen with the Mace's case study this morning and with the Shepherds this afternoon, we've got steel columns in there because we've got some large glazed openings. Obviously, we need to turn around and actually give you, the foundation designers, that loading information, and they need to know where those pad stones are to take that loading as well. So it is quite critical, and there is a process to sort of follow like that. So your slab's gone in, structural slab, whatever that may be. Then we have an upstand up to DPC level, which is your finished floor. That upstand these days nominally is 225 millimeters. That then allows you to put 6 inches of polyurethane in there and a 2-inch screed in there on top and run your underfloor heating in. If you're going to turn around and start looking at U values of sort of 0.12, 0.11, 0.1, that needs increasing up to 300 mil. Obviously, you need to get a good U value through the foundation. So we've got your block upstand in, and that's under all external walls, all internal walls, whether they be load bearing or not. So our sole plate, which sits at DPC level, goes around the whole footprint and springs up. So that's pre-cut in the factory to a drawing. That's the point when we come to put the sole plate down and laser the slab and find out, is it going to fit or is it not? And that's always the $1 million question. And that's always the fear you can see in some clients when they're thinking, will it, won't it? Is there going to be tears before bedtime? So the sole plate's gone down, DPC underneath, and then your panels come in. So your panels then, whether they're in Techie or Tech S, in then pre-insulated as we were showing you before, and then your internal panels the same. Obviously, from an air tightness point of view, you can see the blue membrane down the back. So everywhere where an internal wall meets an external wall, we need to put a membrane down there so that we can actually join the air tightness up afterwards. Once those ground floor panels have gone in, one of the big things that have changed now has been over the last few years is the floors are all engineered joists. So we've gone away, people say, well, will the floor squeak? No, the floor won't squeak. Well, I used to have a house where the floor squeaked. That was in the days of using solid timber joists, chipboard floors which weren't fixed down or glued down properly, and obviously that solid timber drying out. So as it dried out, it shrunk, and then you've got gaps, and then it was pulling on the nails. Now we use a metal web joist which is top hung supported, so it enables us to take our wall panel all the way up and then top chord support the joist onto it. Our joists are all minimum 254 mil deep. So the idea being then, for those of you who spoke to Dave Hilton this morning, with the heat, mechanical ventilation and all the services, we can run all the services straight through the joists, no problem at all. So there's no notching, no cutting. But again, it's one of those, if we are going down the route of mechanical ventilation, and obviously that's something that's climbing more and more these days, we need that design. So you need to have made your mind up who you want to use and get your order with them so that we can get the design off them as we start designing the timber frame. Because obviously, yes, we can run all the ducting through here, no problem at all, but guaranteed where we've got to change of direction or we've got beams in the floor, we need to make holes in those beams before it arrives on site. It isn't a matter, as somebody said to me, well, can't you send it to site and then cut the holes in afterwards? No, we don't do that. It all gets designed and done in the factory, because at the end of the day, it could be a case the engineer says, well, yeah, once you cut the hole in that on site, we need metal stiffeners or something on it. Well, we don't want to be doing that on site. We want to be doing that in the factory before it arrives. So, get that design done, and job done. And again, those joists, if we're on bigger spans, we can make those joists deeper. So at the end of the day, we've got a 254, they can go 304, 356. So we can span, and they don't necessarily get more expensive the deeper they are. So it's one of those, sometimes it's cheaper to have a deeper floor zone and get rid of some of the steelwork in there, rather than keeping the floor slimmer and putting steelwork in. So we'll turn around and go with some the decking on then. So obviously our floor's gone down, and bearing in mind, as we were talking this morning, timescales wise, your timber frames arrived. Your ground floor's gone up in a day. Your floor joists have gone up. Your floor's gone down in a day, and we're ready to turn around and actually start decking it. It's phenomenal that you can be thinking by the end of by the end of day 2, we've actually got the floor on and ready to go again for first floor, which again, with the weather we're getting at the moment is why obviously there's so much more traction with a timber frame wanting from that time scale. So your floor's gone down. Obviously, I'm not going to glue it down, otherwise we won't be getting it apart for the next one. And obviously the floor's got a peel clean membrane on it. So the floor is actually a moisture resistant chipboard. And then this peel clean membrane gets taped on all the joints and gets taped on the fixing joints the other way as well. That membrane stays on there until the very end, because the idea being that membrane keeps the floor dry during construction, because obviously we're building these places 12 months of the year and we're getting wetter in the summer than we are in the winter. So that'll keep it dry, but also during the build then, whilst you're sort of plasterboarding and skimming out and painting, you don't need to worry quite so much about making a mess on the floor, because that will all get ripped up just before you put your carpets down. So that stays in until you've second fixed. And then literally as the carpet fitters are coming in, you can go around the outside of every room with a Stanley knife, cut it and just peel it off. So you're ready then, and obviously we were talking about your air tightness as Andrew pulled that up over. So that sits on our ground floor panel before the joist goes on. Then that flips back over on the floor so that can actually tape down on the ground floor, and then that will tape up on the first floor so that we can actually maintain that air tightness all the way around. Because the secret with the air tightness is to be able to take on the section of the drawing, you need to be able to take a pen from DPC up the inside of the panel, round the floor, up the inside the panel, round the roof, round any purlins and back to the floor. And if you can do that without taking the pen off the drawing, you've got an airtight house. If you've got to turn around and actually pull that off and think, how am I going around that? There's going to be a leak. They're like that. So so first floor panels come in. He will lift it high enough. So panel goes on, and as we said, another day your first floor panel goes up. Sorry. So they've gone in, and as we said then, so all pre-manufactured, ready to roll, and then your first floor is complete. That's him. So whichever, as we sort of said, whichever system, then the first floor's gone in. And then one of the things we were saying earlier from your liner boards, to turn around and actually maintain, as we were talking about on the ground floor, that liner goes on the inside, the membrane tapes to it, that liner goes on the first floor, and the membrane tapes to that. Obviously, the liner sits in there, tapes up, and then your service batten goes on top of it. That's why your service battens stay shorter top and bottom. So that then gives you that sort of consistent run right round. So then you've turned around and got your first floor panels up, and you're getting to roof level. If I bring that sort of there, hopefully we can all see it. So then people say, well, actually, from a design point of view with a timber frame, what roof can I put on it? You can put any roof you like on that timber frame, as long as we design it in. So whether it be normal think trusses, not a problem. Whether it be double bobtail trusses, obviously there's a lot of double bobtail trusses getting used now where we're putting steel purlins or laminated timber purlins through the roof space to support little trusses and then rafters down. That's a very cost-effective way of achieving a roof when we've got like a cottage style where you've got like a 1.5 story and you've got dormers or roof lights in. Whereas if you were doing that in full trusses, you'd have to be multiplying all the trusses up either side of the openings. Whereas that way round, we can just run the purlins through, run the trusses through at 600 centres, and then our rafters, then it's just the rafter element that you're multiplying up then either side of it. So that again is, as I said, is quite a popular solution. Then obviously we've got a raised tie truss, and talking to some guys this morning, I was saying that again, taking you from a standard 8-foot ceiling, a raised tie truss is a massive improvement on giving you that little bit more headroom without going fully vaulted, because everybody's sort of thinking, right, going from flat ceiling straight to fully vaulted. But the thing is, the construction of that is more expensive. The actual finishing of it is more expensive. The insulating of it is more expensive. So don't jump from one extreme to the other if you don't necessarily need to. So raised tie trusses, usually we can get another sort of 2 foot, 600 mil with that. That does make a massive difference. So you're then into sort of a 9 foot 6, 10 foot ceiling. So that works quite well. Or as we said then, you'll go into a fully vaulted solution, which, yes, not a problem. Depending on the spans, we're actually running that with either softwood rafters, or if we're doing it with our TechVantage system, we're actually using metal web rafters. So the metal web joist we use on the build system, we can actually use that as the rafter. And again, then we can turn around and purlin that through so we can get sort of 300 mil of insulation. So if we've got big spans, we'll use the metal web rafter. And if we've got very, very low thermal performance, we'll use that metal web rafter so that we can get the depth of insulation in. And then the idea with both of those then, obviously that's giving you sort of full space inside, fully vaulted, especially if you've got sloping gable glazed windows and that in the gable ends. And then obviously on the bottom left, we've got attic trusses, which have been around a long time. So that's another one giving you room in the roof space. But a lot of time now we'll use an attic truss, or we will sort of use a combination of the attic and the double bob, because with that we can turn around and just floor straight through. Because obviously with an attic truss, once we start chopping it out for dormers and things like that, then it makes the floors more complicated. So yes, we can stick any kind of a roof on top of a timber frame as long as we design it in. So then they say, well, what can I clad it with? And because it's a timber frame, is there any limitations to what I clad it with? No. Again, as long as we know what we're designing it in for. So if we're putting slates on there, not a problem. We just need to design it in because it's very heavy. If somebody wants to, as we did one last year with cedar shingles, not a problem because it's really, really light. But again, we need to know about that at design stage, so that makes our roof more cost effective because we're not designing the weight and the roof to take the load of a slate roof. But actually, when we go to use cedar shingles, we have the opposite effect, because obviously not so much the load issue, but the uplift issue. So it's not a case of thinking, well, actually we'll put slates on there because we'll go for the heaviest loading and then we might change our mind later. We can't be doing that. We need to design it. Again, it's an engineered solution. So do your legwork, do your research, and then turn around and actually set it based on what it's designed for. And then even now, as we're starting to see a lot of traffic moving into standing seam roofs now, and the metal roofs, and people are like, can we put a standing seam roof on the timber frame? Not a problem. We will then deck that roof with an 18mm OSB board, which is the same as the board we use on the outside, but twice the thickness. So that goes all over the outside. Again, the only thing we need to do, as we're finding with metal web roofs, is every different manufacturer has a different detail of how that's going to work. And so it's a case of some of them will turn around and allow us to have an 18mm on top of the rafter, and they will then put their metal deck on top of that. We can insulate inside. Some of them want a secondary ventilation above it. Some want a secondary below it. So again, it's a matter of during our design, and especially if we're doing the building regs, as I was saying to you this morning, another big sort of traffic gain for us is we're over 90% of the projects now, we're doing all the working drawings and all the building regs. We need to know at that stage, it's a metal roof, but we need to know who the metal roof is provided by. Because as I said, I know now if I went out to 6 metal roof guys, I'd have 6 different details to sit on that timber frame. So as much as sometimes people want to leave the decisions till later, I think in the market we've got now, the more we can actually tie it down with actually getting those details sorted early doors. So that gives you the options for the roof in the way of the different structures and the different finishes. So the last one to cover then is obviously on the outside of the timber frame. People say, well, what can I clad it with? You can clad it with whatever you like again, but make sure we're designed for it. So don't tell us we're going to turn around and have that lovely 4-bedroom house and we're going to brick it up. And then you decide about them sort of a month before the timber frame arrives on site. Actually, we've decided we don't want to brick it up. We're going to turn around and timber clad it, or we're going to lightweight clad it. Because suddenly that does make a difference to our engineering, and it does make a difference to the wind loads and that imposed on it. But bearing in mind these days that only 1 in 4 / 1 in 5 timber frames have actually got a masonry cladding on them. You can't believe how much lightweight cladding is getting used now, whether it be brick slips, render boards, timber cladding. There's a lot of the tile hanging. There's a lot of lightweight claddings out there. And to be honest, it's only going to increase because, as we said, it gives you a thinner wall construction, so it increases your floor area, but also it has other sort of advantages like that. So again, think about, and even if you want to combine the two, where we turn and have brickwork on some elevations or lightweight cladding on others. But the other thing to think about is if you've got areas where we're seeing a lot more glazing in these houses now, and we're seeing a lot more sort of bigger bifold doors and sort of corner glazing and gable glazing. That's ideal for then using lightweight cladding, because otherwise it'll cost you a fortune in lintels to support masonry over those areas, and obviously big design details to try and do that. Whereas if you can batten that out and put lightweight cladding on there, again, that makes it life a lot easier. And that's something we will pick up during our building regs and during our working drawings to actually steer you with that. So hopefully that's given you a bit more in depth. Again, bit of a quick sort of run through, but I think it just sort of captivates hopefully as well with this morning of where timber frame is going and what it can actually do. And it's amazing what it can actually achieve these days, and really why you're seeing 75-80% of self-builders building in timber frame, because they want a quality, speed of build, and a predictable structure. Thank you very much.